Hello there, I am Dr CN Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Alright, so we have 0 to 8. Then we have our frequency given as 5, 10, 15, 20, 25, 20 again, then 15, 10, and then we have 5. Now for this situation, remember to find the moment, we must first find the mean of the deviation. We have to find the mean of the distribution. So to find the mean of this distribution with frequency, we will have our formula given as mean summation of our frequency multiplied by our x value all over summation of f. That is summation fx all over summation f. So we must do this. We have to find summation. We have to find fx. 0 times 5 will give us 0. 1 times 10 give us 10. Follow me wherever you are on this. 2 times 15 will give us 30. 3 times 20, 60. 4 times 25, 100. 5 times 20, 100. 6 times 15 gives us 90. 7 times 10 gives us 70. 8 times 5 gives us 40. Then we have to find the summation of fx. And the summation of fx will give us, can you do that on your own now? Thank you. We'll have 500. And what is the summation of f? Can you do that? Summation of f, if you sum that, it should give us 125. So that our mean will give us 500 divided by 125, and that gives us 4. Is that what you got? 500 divided by 125 will give us 4. So our mean is 4. The next thing we do is to find the deviation from the mean, and that is our d. Remember, d here is x minus x bar. So that is all these values minus this value of mean. Can you go along with me as we do that? 0 minus 4 will give us minus 4. 1 minus 4 will give us minus 3. 2 minus 4 will give us minus 2. 3 minus 4 will give us minus 1. 4 minus 4 will give us 0. 5 minus 4 will give us 1. 6 minus 4 will give us 2. 7 minus 4 will give us 3. And 8 minus 4 will give us 4. That's our first deviation. But then because we have frequency here, we will not assume that this is our first degree of deviation. We have to multiply our deviation by the frequency that we have. So that means we have to have fd. So fd becomes our first degree of deviation. So fd will be multiplying these values in our frequency column against these values in our deviation column. Can you go with me on this? We have 5 times minus 4 will give us minus 20. 10 minus 3 times minus 3 will give us minus 30. 15 times minus 2 will give us minus 30. 20 times minus 1 will give us minus 20. 25 times 0 will give us 0. 20 times 1 will give us 20. 15 times 2 will give us 30. 10 times 3 will give us 30. And 5 times 4 will give us 20. I trust you are following with me. Then we look at the second degree of deviation, which is fd raised to power 2. To get fd raised to power 2, we have to multiply our deviation times fd. Deviation times fd. Now that will give us, now look up here, we have d times fd. D times fd will give us f, standing as Odin, we have d raised to power 2. Remember, this is 1 and this is 1. And according to the law of indices, we have 1 plus 1 will give us 2. That's why we have fd. So to get the values for this will be the deviation times this. Now let's do that very quickly. Minus 4 times minus 20 will give us 80. That will be positive. Minus times minus is plus. So this times this, minus 3 times 30 will give us 90. Minus 2 times minus 30 will give us 60. Minus 1 times minus 20 will give us 20. Then 0 times 0, 0. This will give us 20. This will give us 60. This will give us 90. And this will give us 80. Alright, so that's our second degree. We now go on to look at the third degree deviation. That is fd raised to power 3. Fd raised to power 3 will be this deviation, these values times these values times the values of fd raised to power 2. That's how we have fd raised to power 3. So let's go on with looking at what values it will give us. So minus 4 times 80 will give us minus 320. Minus 3 times 90 will give us minus 270. Minus 2 times 60 will give us minus 120. Minus 1 times 20 will give us 20. 0 times 0 will give us 0, which is 20. Then this will give us 20. This will give us 120. This will give us 270. And this will give us 320. So that's our third degree deviation. Then let's look at the fourth degree deviation, which is fd raised to power 4. To get fd raised to power 4, the fourth degree deviation, it will be to multiply our deviation column. We have the deviation column multiplied by the values you have in fd. So can we do that together very quickly? Let me turn to this side of the board. So by the time you have d times 320, you are going to have 1280. Mind you, this is minus times minus. That's why it is positive here. Don't make a mistake. The next one will give us 810. The next one will give us 240. You can confirm that very quickly with your calculator. The next one will give us 20. The next one will give us 0. The next one will give us 20 and 240 and 810. And then we have 1280. We now have to find the sum of these degrees of deviation. This first four, this ones 1, 2, 3, 4. We have to find the sum. Can you do them very quickly? The sum of fd. What is it giving you wherever you are? The sum of fd, it should be 0. Thank you. So your first degree deviation should result in 0. Now the second degree deviation here, what I have my solution. Can you do that very quickly? Thank you. You're following? You have 500. That's what we have here. Then the third degree deviation, what do you have? If you look at what we have on the board, I think there's an error here. There should be minus here. Okay, thank you. There should be minus. So if you have, these are all negatives and these are all positive of the same value, so this should be 0. Then if you add all this together, what you have is 4700. That's what we have. The next thing we do, I haven't found the summations, is to now calculate our moments. We now need to calculate our moments. Our first moment given as mu1. Now the formula is going to change a little. The formula will be summation Fd all over n. Summation Fd all over n. I am using this capital letter N because the sample size we have is more than 30. It's a large sample. That's why we have N here. So summation Fd, which is 0, look at it. The summation Fd is 0 all over 125. Our N is the value of the summation of the frequency, that's N, 125, and that's going to give us 0. Our second moment, which is summation Fd raised to power 2 all over n. What's that going to give us? That's giving us 500 all over 125, and the answer we have is what? 4. Thank you. The answer we have is 4. So the third moment is summation Fd raised to power 3 all over n. And what do we have? We also have 0 here. We have 0 divided by 125, and the answer will be 0. This shows that this is a measure of the skewness of the distribution. It means that it's a normal, very normal distribution. There's no negative skewness or positive skewness of the values in this distribution. That's 0. And we have our fourth moment, which gives us summation Fd raised to power 4 all over n. And what do we have? We have 4700 all over 125. And what is our answer? Our answer is 37.6. Alright, so if you've followed me in looking at this solution, you see that the first 4 moments of this distribution is given here, as you can see on the board. If you have any comments, you can place a line or 2 on the comment section of this video. Thank you.